Okay, we're going to continue on with the physiology of what's happening in the bone. We ended the last video talking about that we need that calcium to be kind of in a range of levels. I'll flip back to that. That in the blood we would want it to be between 9.2 and 10.4 micrograms per deciliter. No, milli, sorry. And so then we're going to move into what happens if it's not, okay, and what's the body's response going to be. So hypocalcemia would be a blood calcium deficiency. Anytime you see the prefix hypo, you should be thinking low. And so if there's not enough calcium in the blood, we are going to see those muscles are going to contract because they don't have the calcium, because the sodium is entering the cell too easily, and so that excites the nerves and the muscles. So without the calcium, those muscles are basically contracting like crazy. And then in contrast to that, hypercalcemia, if there's too much blood calcium, the sodium channels are less responsive, and so then the nerve and the muscle cells are less excitable than normal. So we might see depression or slow reflexes. Hypercalcemia is rare, but hypocalcemia is more common and has a variety of causes. And I'm not going to read through all those, but lots of causes, because if you think about the calcium homeostasis is depending on lots of different factors. So it depends on your dietary intake. It can depend on how much you let out through urination and fecal losses, and then also that exchange between the bone and the blood. So all of those overall are going to have input on this overall calcium level. And so calcium homeostasis is regulated by 3 hormones. Now, here the notes do get very picky. I just want you to know each hormone and overall what it does. So you're going to notice that I'm going to be flipping. So the 3 hormones are calcitrol, calcitonin, and the parathyroid hormone. So they're all working together to maintain that blood calcium concentration, but they're working in different ways. So let's focus on calcitrol first. Calcitrol is the hormone that is raising the blood calcium concentration. So raising the calcium concentration in the blood. It increases the calcium absorption by the small intestine and then increases the calcium resorption from the skeleton. So it is resorption, remember, that is letting, dissolving the calcium from the bone and letting it loose in the bloodstream. So that is how calcitrol helps raise the blood calcium concentration. But calcitonin is the opposite. Calcitonin is lowering the blood calcium concentration. It inhibits the osteoclasts. It slows down their activity by as much as 70%. And so then less calcium is liberated from the bones or released from the bones. And that also stimulates the osteoblasts, which is increasing their number and activity. So they are basically depositing more calcium into the skeleton. So 2 ways, slowing down the release and then also depositing more calcium. So that's calcitonin is lowering the blood calcium concentration. Okay, and then the parathyroid hormone is released when calcium blood levels are low. So calcium blood levels get too low, and then the parathyroid hormone is released, and it will raise the level of calcium in the blood. So all 3 of those hormones working together, signaling. Remember, a hormone is just a signal within the body. Sometimes it's called a chemical messenger, but it's going to a point and saying and telling everyone what to do. So going to the bone and saying, hey, there's too much calcium in the blood. Let's stop releasing calcium. Okay, that's one example. Okay, then this goes through phosphate homeostasis. I'm actually going to slide through that because calcium is more important to me. And then this talks about other factors affecting bone. There's way more hormones and other things to list here. I'm focused on those 3 that we just mentioned for the calcium homeostasis. But as you can imagine, growth hormones, estrogen, testosterone are all going to have an effect on bone growth and ossification.